90% of a coconut was once considered waste. But when technology stepped into the game, that worthless part began challenging the global plastics industry, rewriting the story of sustainable materials and a green economy worth billions of dollars. So how are more than 100 billion coconuts recycled every year? The journey to redefine the value of this tropical fruit begins in fertile regions where tens of millions of tons of coconuts are harvested annually. From there, the parts once thought to be discardable are taken into factories, where modern technology combines with skilled craftsmanship to revive them with entirely new roles. Things you may have never imagined a coconut could do. In today's video, join Agriculture Insight to explore completely new perspectives on coconuts and uncover the secrets that allow humans to transform waste into a sustainable resource for the future. Everything will be revealed right now. For decades, Indonesia, the Philippines, and India have been the undisputed leaders, commanding over 70% of global coconut production. Yet in the arena of byproduct recycling, India stands as the true powerhouse, processing more than 500,000 tons of coir and cocoa peat each year and steering this billion-dollar industry. As the green living movement accelerates worldwide, demand for coir and cocoa peat has surged by 15% annually. What transformed materials once dismissed as agricultural waste into a global phenomenon? It starts with a natural paradox. Coconut fiber is organic, yet as tough as synthetics. Biodegradable, yet slow enough to endure 2 decades before breaking down. Combined with the coconut's near-zero waste nature, these traits have turned its byproducts into a genuine green goldmine. On the benefit side, recycling 1 ton of coconut husk can cut up to 250 kilograms of CO2, but left to rot or burned, that same husk releases methane, CH4, a greenhouse gas 28 times more potent than CO2. In a world facing escalating environmental crises, recycling coconuts is not only an ecological rescue but a remarkably smart way to turn waste into a multi-billion-dollar opportunity. Thousands of products are now born from coconuts, from construction materials, carpets and mattresses, to cosmetics and even road surfaces. Hard to believe? And that is exactly why you're here, to begin this remarkable journey of renewal. Back to the tropical coconut groves, where every new life of the coconut begins. Coconuts are not exactly a cooperative fruit. They grow in heavy clusters, clinging to the tops of 20 to 25-meter trees, turning every harvest season into something of an adventure sport, where a single unlucky slip could easily cost a picker a few non-replaceable components. If in the past, farmers had to gamble with safety by climbing straight up the tree or using long poles to hack down the bunches, both dangerous and prone to cracking the fruit. Today, they have a far smarter solution. Long harvesting poles, designed for just the right reach and tipped with curved blades that are sharp yet flexible, have become the ultimate tool. One clean sweep from an outstretched arm is enough to send a 30-kilogram cluster crashing down. The transportation method is just as ingenious. Shallow irrigation channels dug between coconut rows act as natural shock absorbers, catching the falling bunches from tens of meters above while preventing almost all surface damage. The coconuts are then gathered directly on the water, tied into floating chains like buoy lines, and towed back to the collection point. And that is only the beginning, because once the fresh coconuts reach the processing plant, their second life truly begins. A peeling journey that reveals the precious 30% inside, while the remaining 70%, that rugged outer armor, is reborn as coconut fiber. Thousands of tons of coconut husks pour into recycling plants, stacked into massive mountains, and left under the sun for several days to reduce moisture and soften naturally before entering their transformation phase. Once they reach the ideal dryness, these seemingly useless shells are fed into industrial shredders, where blades spinning at 1200–2800 RPM relentlessly tear, slice, and break apart the tough outer layer. Thanks to the strong cutting force and multi-tier steel blades, the machines can process tons of material per hour, producing a mix of long fibers and fine cocoa dust. This step is critical. The looseness and uniformity achieved during shredding directly determine the efficiency of subsequent cleaning, drying, and fiber separation stages. Fibers that meet the standard move on to screening systems to remove dust before being sun-dried or heat-dried to reach stable moisture levels. Once complete, the coconut fiber becomes a light, durable, and resilient material, ready to be reborn as mattresses, carpets, growing media, or countless other sustainable bioproducts. After being separated from the outer husk, coconut fiber is spread across large drying yards to soak up natural sunlight, preparing it for the next crucial stage, carding. Here, fast-moving cone rollers separate clumps, stretch the fibers, and align them into smooth strands. The result is a clean, uniform fiber stream, making carding essential for the consistency required in later twisting and weaving steps. After being finely carded, the coconut fiber is transferred to the spinning system. Here, the fiber bundles are twisted into small ropes or high-strength yarns, with each rotation tightening the strands and building the durability required for demanding applications. The twisting process binds the fibers firmly together, producing cords that are strong, resilient, and capable of withstanding significant tension. These cords become the core material used for weaving coir mats. Every parameter, twist level, diameter, density, and tensile strength, is closely monitored to ensure exceptional consistency, giving the final mats superior longevity, structural stability, and outstanding surface grip. Once the finished coconut fiber yarns are ready, they are fed into large weaving frames to form mats with the required thickness, density, and decorative patterns. In this stage, the warp threads are stretched tightly across the loom, creating a firm backbone for the mat, while the weft threads are passed rhythmically through each gap. Layer by layer, the two systems interlock to build a dense, stable structure that gives coir mats their signature coarse texture and remarkable durability. Every movement of the loom, whether powered by hand or machine, is calibrated to maintain tension, spacing, and uniformity. This precision ensures that the mats remain resistant to wear, maintain excellent grip, and hold their shape even under heavy use. Weaving is the defining step where craftsmanship and mechanical accuracy converge, shaping raw fiber into a finished product. Once the weaving is complete, the mats proceed to trimming, edge reinforcement, surface finishing, and final packing for shipment. In many traditional workshops, coconut fiber ropes are spread evenly across the floor before entering the sheet forming stage, using a wooden framing tool. This specially crafted frame functions like a hand-driven mechanical mold, with parallel wooden slats set at fixed intervals to guide craftsmen as they pull each strand into place without misalignment. Every lift and drop of the frame applies just enough pressure to lock the fibers in position while forming clean, straight channels across the surface. As the frame moves, workers use wooden mallets to tap rhythmically along the mat, compressing each layer of fiber to create a uniform structure, reduce air gaps, and maintain an even thickness. The process demands a precise understanding of force, rhythm, and fiber tension, skills gained only through years of experience. Through the harmonious combination of delicate craftsmanship and the intelligent design of the wooden frame, the finished coir sheets emerge strong, yet breathable, ready for the next stage of mattress pressing or mat weaving. Yet, the production process does not end there. The light, loose fibers left behind after weaving, too thin and lacking the structural cohesion required for mattresses or mats, are collected separately and routed into an entirely different manufacturing line. Here, This material, often dismissed as mere byproduct, becomes the ideal input for modern thermoforming technology. Golden bundles of fiber are evenly spread across heavy steel molds, forming a precise base layer. When the mold closes, the fibers are subjected to intense pressure, typically between 3 and 8 tons, combined with high heat. Under these conditions, the natural lignin within the coconut husk softens and flows, binding the fibers together from within. This unique mechanism allows the material to take shape without the use of any chemical adhesives, relying solely on the coconut's own organic resin. Only a few seconds later, the mold opens to reveal fully formed biodegradable coir pots. Lightweight, breathable, well-drained, moisture-retentive, and capable of breaking down completely in soil within months. Their naturally interwoven, root-like fiber structure allows plant roots to penetrate the pot walls easily, avoiding the circling and constriction commonly seen in plastic containers. Though these pots cannot match synthetic materials in long-term outdoor durability, they dramatically reduce plastic waste and are increasingly favored by growers and nurseries worldwide. Today, these coir-based containers are exported to more than 40 countries, becoming a small but significant part of the global shift towards sustainable horticulture. The newly formed pots are then moved to the finishing table, where any excess edges are trimmed cleanly to achieve a precise, uniform shape. Each pot undergoes a final inspection for thickness, compression, and surface quality before being packed, completing the coir fiber's transformation into a fully biodegradable product. But the journey of coir doesn't end there. Humble as it has become a key material in sustainable road construction thanks to its elasticity, drainage ability, and strong soil binding properties. Before the coir layer is installed, the roadbed is cleared, moistened, graded, and compacted to the required density. Once the roadbed has been compacted, large coir sheets are laid evenly across the surface. Workers stretch each sheet along the alignment, overlap the edges, and smooth out the entire layer so it conforms tightly to the terrain. After the sheets are positioned, metal stakes are driven through the edges to secure them in place, creating a natural stabilization layer. No plastic, no waste, and at a cost up to 60% lower, making it ideal for rural roads where budgets are limited. With the sheets anchored, the coir immediately begins to do its job, holding soil in place, reducing surface slippage, limiting edge erosion, and dispersing loads across the subgrade. Though biodegradable and temporary, this very trait makes it a sustainable material that leaves no waste behind once its purpose is fulfilled. Immediately afterward, a truck spreads crushed stone evenly over the coir layer. The stones settle through the fiber mesh and lock into its natural structure, forming an effective mechanical interlock. After the layer of crushed stone is compacted by the roller, workers spread a layer of soil over the surface to fill the gaps and increase the stability of the roadbed. A final pass of the roller then locks the entire structure into place, forming a solid foundation for the layers that follow. Finally, asphalt is laid over the compacted base, completing the road surface with a durable, weather-resistant finish. From coarse fibers on tropical farms to mats, mattresses, plant pots, and even sustainable roads, coconut coir is now woven into everyday life around the world. Each year, the coir and cocoa peat industry alone generates more than $4 billion for producing countries, transforming what was once dismissed as agricultural waste into a true green gold mine. And this journey is far from over. As the world accelerates toward sustainable living, the future of coir will only grow broader, brighter, and more promising. If you've never heard of flax before, let me introduce you to this amazing plant. It's easily recognizable by its tall, slender stems and small, lance-shaped leaves. Flax flowers are a soft, light blue, painting fields with a stunning blue hue when in bloom. Flax is grown for two main purposes, producing linen fibers for textiles and flax seeds for oil. Linen is prized for its strength, softness, and breathability, while flax seeds are packed with essential nutrients, especially omega-3s, making them popular in food and cosmetics. In Europe, flax is primarily cultivated for its fibers, while in the US and Canada, the focus is on flaxseed oil production. Flax thrives in cool, temperate climates. Extreme heat or cold, not ideal. Every flax growing journey begins in the fields. Back to early April, when winter has loosened its grip, marks the start of the planting season. Organic fertilizers are often added before planting, providing the perfect foundation for flax to grow. Farmers prepare the soil with care, ensuring it's loose, well-drained, and rich in nutrients. Modern plows help farmers easily plow fields of dozens of acres. For large fields, modern seed drills evenly distribute the seeds across vast areas, ensuring optimal density for healthy growth. When the first green shoots emerge, farmers start taking care of the flax. The plant needs sufficient water but cannot tolerate waterlogging. Flax generally doesn't face many pests or diseases, so farmers just need to ensure proper planting and adequate watering. About 2 months after planting, flax begins to flower. The light blue flowers sway gently in the wind, creating a serene and poetic landscape. This is also when the plant starts accumulating nutrients to develop its fibers and seeds. The harvest time depends on whether the flax is grown for its fibers or seeds. Flax for fiber is harvested when 70% of the seed capsules on the stems turn yellow and most of the leaves have fallen. Early harvesting ensures that the fibers remain soft and of high quality, preventing them from becoming brittle as the plant ages. Flax for seeds is harvested when the entire plant turns yellow and the seeds inside the capsules are fully mature. Fully ripened seeds yield the highest quality and are easier to separate during the harvesting process. Let's dive into both harvesting methods. First, let's head to European countries like France, Belgium, and the Netherlands to witness the harvesting of flax for its fibers using modern machinery. Flax harvesters are specially designed to pull up the entire plant from the roots without damaging the stems or fibers. These machines consist of 4 main components: pulling claws, conveyor belts, cleaning units, and height adjustment systems. The machine moves along the rows of flax, with pulling claws positioned close to the ground to gently uproot the entire plant, including its roots. These claws are engineered to hold the base of the plant firmly while applying a gentle vibration to loosen the soil, ensuring the plants are pulled out intact without breaking or damaging the stems. Once uprooted, the conveyor belts transport the plants from the pulling claws to the stacking area. The flax plants are then neatly laid in rows to dry naturally. As the plants move through the machine, their bases are gently cleaned to remove any soil or debris clinging to them. These machines can harvest hundreds of acres of flax daily, significantly faster and more efficient than manual labor. After being harvested, flax plants are left to dry naturally in the sun for 2 to 3 weeks. This drying process helps break down the natural pectin, a binding agent, in the plant's outer layer, softening the bark and allowing the flax fibers to separate from the woody core inside. Farmers then use specially designed flax gathering machines to collect the dried plants from the fields and bundle them into large rolls or bales. These machines work by using raking teeth or rotating gears to gently lift the flax onto a conveyor belt, ensuring the stalks remain intact without breaking or damaging them. Once collected, the flax is compressed in the machine's baling chamber, forming neat cylindrical rolls. Finally, the flax bales are ready for transport to the processing factory. Upon arrival at the factory, the flax is inspected for quality and cleaned to remove impurities like soil, leaves, and small branches. Next, the softened stalks are then fed into a crushing machine that cracks the tough outer bark. Afterward, they pass through a stripping machine to completely remove the remaining debris, leaving behind the raw flax fibers. These raw fibers are combed through large metal brushes or combs to remove any remaining impurities and are sorted by length and quality. The long, fine fibers are rolled up and carefully packed, ready for use in the textile industry. In addition, they can also be drawn and rolled into larger fibers using specialized machines, making the flax fibers larger, stronger, and more durable during the weaving process. Flax fibers can be used in their natural color or dyed to meet specific requirements. Once dyed, the flax fibers are sent to textile production facilities. First, the long, combed fibers are pulled from their rolls and prepared for weaving. These fibers are arranged into a warp, vertical threads, and weft, horizontal threads system. They are then fed into a loom, which can be either manual or automatic. The loom interweaves the warp and weft threads to create a sturdy and uniform sheet of linen fabric. Modern looms often incorporate electronic sensors to maintain optimal tension and thread alignment, preventing breakage or uneven weaving. The finished linen fabric is then cut and sewn into various products, such as clothing, tablecloths, curtains, and other home textiles. Linen fabric stands out as a favorite among consumers for its remarkable benefits. Its natural breathability and excellent moisture absorption keep the body cool and comfortable, making it ideal for hot and humid weather. As an environmental advocate, I encourage you to choose linen over synthetic fabrics. While linen may cost a bit more up front, it contributes to a greener planet and offers unmatched quality and longevity. Let's embrace sustainable living together. If you agree, give me a like and subscribe for more eco-friendly tips. Let's dive into the process of harvesting flax seeds for oil production. When flax plants are fully mature, their stalks turn from green to golden brown, signaling the right time to harvest. A harvester, similar to a wheat combine, moves through the flax fields to begin the job. These machines are equipped with seed collection bins mounted directly on the body for convenient gathering and transport. As the harvester moves along the rows of flax plants, sharp cutting blades trim the stalks close to the ground or collect the entire plant. The stalks are then fed into a threshing chamber, where the seeds are separated from the stems through mechanisms that crush and sift the material. The seeds are conveyed into a large onboard storage bin via an internal conveyor system, while the leftover stalks and husks are discharged as mulch behind the machine. The harvester's large capacity bin reduces the need for frequent unloading, maximizing efficiency on large fields. With its modern design, the equipment ensures high productivity while preserving the quality of the seeds for the next processing steps. The harvested flax seeds are screened to remove debris, husks, and impurities. They then go through a cleaning process, where advanced airflows or fine sieves remove any remaining soil, dust, or subpar seeds. After cleaning, the flax seeds are sent to an oil extraction facility. Here, the seeds are crushed to break their outer structure, making it easier to extract the oil. This process is conducted under carefully controlled temperatures to preserve essential nutrients like omega-3 fatty acids. The oil is bottled and prepared for the market. Due to its sensitivity to oxidation, flaxseed oil is packaged in dark bottles to maintain its quality. Flaxseed oil has a light, slightly nutty flavor and a natural aroma. Now you have a clear overview of how flax plants are grown, cared for, harvested, and processed into high-quality fibers and nutrient-rich flaxseed oil. If you have any questions or thoughts, feel free to share them in the comments below. Don't forget to like this video and subscribe to the channel so you won't miss out on more fascinating stories about agriculture and production. Goodbye, and see you in the next video. Among the more than 4 million alpacas living around the world, up to 90% are found in Peru. The rest are scattered across Bolivia, Chile, Ecuador, and even the United States and Australia, making Peru the true alpaca capital of the world. Here, alpacas are not just livestock, but also a national cultural symbol, appearing on coins, in folk art, and in the vibrant traditional festivals of the Andes. Although they exist in only a handful of regions, alpacas are famous worldwide for their bizarre spitting behavior found only in this species. But have you ever wondered why they do it? In fact, it is a form of body language. When angry or trying to assert dominance, they build up air and spit out a mixture of saliva and stomach fluids with a pungent odor. A warning to their opponent and a way to maintain order in the herd without resorting to fighting. Every year, the alpaca industry generates more than $300 million USD thanks to their fine, lightweight, and hypoallergenic fleece. Compared to cashmere or sheep's wool, alpaca fiber is warmer, more durable, available in up to 22 natural colors, and competitively priced, making it a favorite choice of luxury fashion houses such as Armani, Prada, and Loro Piana. And every journey has a beginning. Right now, let's return to where it all started. The alpaca farms of the Andes highlands, where the magical journey of the alpaca truly begins. Unlike cattle, goats, or sheep, alpacas eat very little, surviving mainly on natural grass and hay. They don't require industrial feed, simply lay out clean grass, and they will calmly stroll over to graze at their own pace. Here's an interesting fact. The happiness of these gentle camelids is the golden key to producing top-quality fleece. That's why most alpacas are raised in semi-free-range systems or through pasture rotation across the vast highlands of the Andes. This method of grazing not only reduces feed costs, but also allows the herd to move freely, keeping them relaxed and ensuring optimal fleece quality. Moreover, when feeding on natural grasses, alpacas don't uproot the plants but only nibble on the tops. This helps protect the soil and maintain vegetation cover. Their unique three-chambered stomach enables them to absorb nutrients with exceptional efficiency, extracting the maximum value from their modest diet. It is precisely this extraordinary ability, eating little yet staying strong, that makes alpacas an ideal choice for sustainable farming, where even a handful of grass can be transformed into some of the world's most precious fibers. However, producing premium fleece from happy alpacas requires more than just a healthy diet. Daily care is equally important. From regularly cleaning their pens, since each alpaca can relieve itself a dozen times a day, to carefully managing vaccinations and parasite control, every task is carried out with precision and with great respect for the herd. Breeding is also strictly managed through selective programs aimed at improving both the fineness and the natural color quality of the fleece. Thanks to this, alpacas today can produce more than 22 natural shades of fiber, making them one of the domestic animals with the most diverse color ranges in the world. When it comes to pregnancy, alpacas receive just as much attentive care. If you are familiar with how horses or cattle are looked after during gestation, you can be assured that alpacas are cared for to the same degree, including routine ultrasounds to ensure the fetus is developing healthily. After nearly a year of pregnancy, the mother alpaca usually gives birth to a single offspring while standing, and the delivery takes place smoothly, guided by the patient instincts of a devoted mother. The newborn, called a cria, typically weighs between 6 and 9 kilograms at birth. What is particularly remarkable is that, although wobbly at first, a cria can usually stand up and take its very first steps within less than an hour of being born. Over the next 2 to 3 years, this tiny being will grow into a fully mature alpaca, weighing between 55 and 80 kilograms, ready to embark on a new chapter of life, its very first shearing. Before the process begins, alpacas are brought into a quiet, clean area to minimize stress. This preparation step is especially important because alpacas are highly sensitive animals. Even a slight fright or sudden movement during shearing can cause them to panic, resist, or fall into extreme stress. For this reason, to ensure the safety of both the animals and the handlers, alpacas are usually secured gently with soft ropes or placed on their side on a cushioned mat, a far more comfortable and humane approach than suspending sheep during shearing. However, don't mistake shearing as a burden for alpacas. If left unshorn, their fleece will grow thick and heavy, restricting movement, trapping heat, and silently threatening their health. Shearing leaves alpacas feeling lighter and more comfortable, free to frolic, breathe easily, and enjoy the cool summer breeze. Each alpaca can yield between 2 to 4 kilograms of fleece per shearing season, and among this, the fleece from the very first shearing, known as baby alpaca, is the most valuable, prized for its exceptional fineness and uniquely soft texture. This means that at every harvest season, thousands of tons of alpaca fiber are only halfway through their journey, from the remote highlands to modern mills, where they are cleaned, sorted, refined, and spun into premium yarns, ready to enter the world of luxury fashion. After harvesting, alpaca fleece is carefully packed into large sacks and transported to artisanal processing facilities. Here, a meticulous, entirely hand-operated process begins. Workers open each sack and spread the fleece out on wide tables for inspection. With keen eyes and seasoned hands, they sort the fibers according to natural color, length, softness, and cleanliness. This is no simple task. A single facility may receive hundreds of kilograms of fleece each day, and every tuft must be assessed individually with great care. The finest fibers, known as baby alpaca, are set aside with special attention, while coarser fibers are reserved for products such as blankets or rugs. The entire process is carried out without heavy machinery, preserving the natural structure and inherent value of the fibers. After being sorted, alpaca fibers continue their journey to the washing area, where the cleaning and preliminary carding process begins. Unlike sheep's wool, which contains natural lanolin, alpaca fiber does not, making the washing gentler, requiring no harsh chemicals or excessively hot water. This makes the process both eco-friendly and safe for sensitive skin. Here, the fibers are soaked in warm water at 45 to 55 degrees Celsius, mixed with biodegradable soap. While this temperature is not enough to boil an egg, it is just right to soften the fibers, allowing them to be untangled, freed of impurities, and aligned smoothly, ready for the next stage. After being thoroughly washed and combed, alpaca fibers are moved to the drying area. Here they are placed into specialized dryers, operating at a controlled temperature of around 60 degrees Celsius, the ideal level to remove moisture while preserving the softness and natural structure of the fibers. The drying process is gentle and even, ensuring that each strand maintains its elasticity and original quality. Once fully dried, the fibers enter a crucial stage of transformation, carding. During this stage, the fibers pass through a series of rotating drums covered with fine metal teeth, working like delicate combs. These rollers remove any remaining impurities and align the fibers in the same direction. The result is continuous, lightweight, and airy strands, known as mica. Depending on the machinery and fiber fineness, each carding machine can process between 15 and 30 kilograms of alpaca fleece per hour. Once formed, the mica strands are either rolled into large bundles for storage or sent directly to the spinning section. This bundled form not only preserves fiber quality, but also makes handling easier in the subsequent steps. Through this delicate, yet essential process, alpaca fleece gradually takes on a new form, becoming uniform, soft, and durable mica strands. From here, the entire process shifts to mechanization. The fibers are fed into industrial spinning machines, where they are carefully stretched and twisted to create fine, strong, and consistent yarns. Once completed, the yarns are automatically wound onto cones or bobbins, ready for weaving, continuing their journey toward becoming sustainable fashion products. After being carefully treated, alpaca fibers enter the dyeing stage at a gentle 35 to 40 degrees Celsius, using eco-friendly biological dyes that allow the colors to penetrate fully while keeping the fibers naturally soft. Once dried and wound onto cones, they reveal a vibrant palette, ranging from warm, earthy tones to vivid, luxurious shades, ready to be transformed into exquisite handicrafts or captivating modern fashion. In some factories, alpaca fibers are dyed while still in their raw form, a distinctive approach that brings notable efficiency. Instead of going straight into spinning, the fibers, once cleaned and prepared, are immersed in large dye baths at a gentle 35 to 40 degrees Celsius, using eco-friendly, biodegradable dyes. Afterward, they are carefully dried at moderate temperatures to remove all moisture while preserving their elasticity and natural structure. Once dry, the vibrantly colored fibers move on to the spinning stage, where they are stretched and twisted into fine, strong, and uniform yarns. These yarns are then wound onto cones or bobbins, ready for weaving, knitting, or embroidery. By dyeing the fibers early, manufacturers achieve yarns with consistent color throughout, reducing the need for later treatments, saving both time and costs, while producing sustainable, high-quality materials, perfect for exquisite handcrafted pieces or modern fashion. After the dyeing and drying process is complete, alpaca yarn, now soft, durable, and rich in color, is ready for weaving. At this stage, the dyed cones of yarn are placed onto high-precision industrial looms, where each thread is carefully interlaced to form wide, even fabrics with an elegant texture. Thanks to advanced automated technology, these looms can produce meters of fabric at impressive speeds while maintaining exceptional quality. The precise alignment of threads ensures a smooth surface free of knots or flaws, ideal for crafting premium fashion pieces. The final texture of the fabric depends on the type of yarn used. Finer yarns yield lightweight cloth, perfect for scarves or delicate garments, while thicker yarns create sturdy fabrics suitable for coats, ponchos, or warm blankets. This process not only preserves the natural softness of alpaca fibers, but also enhances their color, warmth, and luxurious feel. As a result, each meter of woven fabric becomes a perfect canvas for garments that blend the heritage of the Andes with contemporary design. From the humble fibers of the Andes highlands, alpaca has embarked on a journey of exquisite transformation, becoming fabrics that are soft, durable, and luxurious. Each creation carries not only the breath of nature, but also serves as a bridge between age-old traditions and contemporary style. Unlike outdoor farming systems that require constant water exchange, a recirculating aquaculture system only needs a very small amount of new water added each day, less than 10 liters per cubic meter, while a traditional pond may need up to 1,000 liters for the same volume. The remaining water is retained and treated within the closed-loop system through 3 continuous processes. The first stage filters out solid waste, such as fish feces and uneaten feed. Next, the biofilter converts toxic ammonia into safe nitrate. Finally, the water passes through an ozone or UV sterilization chamber to eliminate pathogens before returning to the culture tanks. Within just a few minutes, the water is cleaned, stabilized, and reused up to 99%, keeping temperature consistent and conditions nearly sterile. This ability to renew the environment almost instantly turns RAS into a programmable, fully controlled production system, eliminating the traditional limitations of space and natural water conditions. Across Asia, behind the nearly 5 million tons of white-leg shrimp exported each year, lies a decades-old paradox. The pond bottom, where shrimp spend most of their lives feeding and breathing, is actually the most oxygen-deprived layer of the entire system. As traditional paddle wheels only stir the surface without addressing this fundamental bottleneck, the shrimp industry has been forced to confront the root of the problem. Oxygen must be delivered exactly where the shrimp live, not left floating in the upper water column. This is why pure oxygen technology emerged as a true turning point. Instead of relying on slow natural diffusion, the system extracts pure oxygen from the air, compresses it into high-pressure microbubbles, and drives it straight into the pond bottom, a zone that almost no previous technology could reach. As a result, shrimp don't just breathe better, they escape the toxic bottom environment entirely. Their metabolism improves, immunity strengthens, and survival rates can increase by around 20%, a number powerful enough to redefine the profitability of an entire farm. Unlike traditional square cages, circular cages use an arched load distribution structure. In this closed-loop design, forces from waves, wind, or currents are evenly spread across the entire frame, instead of concentrating at a few stress points as in square cages. As a result, the cage does not twist, shift off-center, or develop fatigue points that lead to long-term structural failure. When a large wave hits one side, the force is carried around a circular frame, allowing the cage to move smoothly with the wave, rather than resisting it. This absorb-disperse balance mechanism enables the structure to maintain its shape, even in seas with 3 to 4 meter waves. Waters with strong currents and high dissolved oxygen, ideal for species like salmon, yellowtail, and tuna to grow naturally, build muscle mass, and improve flesh quality. Most veteran marine engineers consider offshore circular cages the true starting point of industrial open ocean aquaculture. Since their introduction, marine farming has finally been able to move beyond shallow coastal zones and into deeper, cleaner, and far more stable waters, suitable for large-scale production. Not every sustainable aquaculture model requires closed-loop systems or massive steel structures in the open ocean. In Coffin Bay, South Australia, where the tide rises and falls twice a day and the water is rich in plankton, farmers choose to work with the environment rather than replace it. Each year, rows of oyster baskets are positioned exactly within the most active flow layers, allowing oysters to grow according to their natural physiology. These baskets are made from ultra-durable polymers and designed as rotating cylinders suspended on an adjustable lawn-line system. As currents pass through, each basket rotates gently, smoothing the shell surface, removing fouling organisms, and channeling oxygen down to the bottom, helping oysters build thicker shells, deeper meat, and a perfectly shaped cup. Each basket is less than 30 centimeters wide, yet its rigid frame can hold around 200 juvenile oysters. Thanks to the optimal water conditions and a farming method built entirely around natural current dynamics, Coffin Bay oysters not only reach market size, but also develop thick shells, deep cups, and uniform shape, qualities rarely achieved in conventional oyster farming. This distinction is what allows Coffin Bay oysters to be welcomed in demanding markets such as Japan and Singapore, where consumers are willing to pay significantly higher prices compared to standard farmed oysters. Compared to offshore cage farming, where fish and shellfish grow in HDPE structures engineered to withstand 3 to 4 meter waves, high oxygen levels, and constant currents, the intertidal rack and stick method represents a minimalist but intelligent approach. Instead of relying on steel frames, dozens of hectares of tidal flats use more than 50,000 stakes, working entirely with natural water cycles. Cage farming delivers high output and industrial-scale production, while intertidal farms produce oysters with thicker shells, firmer meat, and a distinct flavor shaped by the natural dry-wet rhythm that no artificial system can fully replicate. To catch hake, modern trawlers rely on a fishing system that is almost fully mechanized. The entire net, stretching 300–500 meters, is packed into a massive hydraulic net drum weighing tens of tons. When sonar pinpoints a moving school, the captain triggers the release. 2 trawl doors swing open, holding the mouth of the net steady at the exact depth where hake are swimming. Throughout the tow, sensors mounted on the doors constantly transmit data on tension and depth, allowing precise adjustments within seconds. Once the code end reaches capacity, typically 20 to 40 tons of hake in a single haul, the drum reverses, retrieving the net along a programmed path that minimizes twisting and stress. As the code end breaks the surface, a single latch is released, and the entire mass of hake spills onto the deck, completing a harvesting cycle driven almost entirely by heavy machinery and automation. But their ambitions didn't stop at the 10-kilometer mark. China's leading engineers pushed even further, developing an industrial-scale fish farming system capable of operating stably in open waters as far as 60 kilometers offshore. With a diameter of 180 meters and a semi-submersible steel frame weighing more than 7,000 tons, the entire structure is assembled on land before being towed to its ideal offshore location. A zone with strong currents, clean water, and minimal human influence. These conditions allow the fish to develop firmer muscles, lower fat content, and overall better health compared to those raised in nearshore farms. Seaweed farming may still be unfamiliar to much of Europe, but a movement to build offshore seaweed farms is emerging as a natural extension of the blue economy. In Norway, commercial-scale farms now operate on 15 to 20 hectares, with long-line systems stretching for tens of kilometers, producing hundreds of tons of seaweed each season. These ocean fields rely entirely on natural currents tides, and nutrients drifting from nearby fish farms, allowing seaweed to grow without fertilizers or chemicals, a truly ocean-based form of agriculture. Seeded in autumn, the seaweed matures quickly, and after just 6 to 8 months, farmers can harvest it using mechanized equipment, where lifting, hauling, and collecting have become almost fully automated. Although European offshore farms have yet to reach the multi-thousand-ton scale of Asia, they are demonstrating a different kind of value: carbon absorption. According to recent trials, each hectare of seaweed can capture 10 to 30 tons of CO2 per year, depending on species and current strength, a number significant enough to position seaweed as a key piece in Europe's long-term decarbonization strategy.